Welcome to lesson number 5 on functional groups. Our lesson objectives: identify functional groups and name substituted hydrocarbons. For this lesson, I'm going to use table R, which is our organic functional group table. It gives us our class of compounds, which result when we add these functional groups to hydrocarbons. And this next column here, these R's represent just the number of carbons, and allows us to identify when we add the functional group. Is it located in between carbons, like in the middle, or is it terminal at the end of a branch or chain? To name or draw these substituted hydrocarbons, we're going to use table R as a guide. We're going to use the condensed structural formula example they give us and the name, and use that to compare to our example. So the first class of compounds that we come up with is the halide. And the halide has a group, one or more groups of halogens, group 17 elements attached to it. So here are our functional groups, our halogens. And so what we're going to do is we're going to look at how they name their example, and then we're going to use that as a guide to name our examples. And we're going to do that for all our compounds. So it says 2-chloropropane. Prop means 3 carbons, 1, 2, 3. That's where the propane comes from. The chloro comes from the attached chlorine, and 2 indicates on the second carbon. So you can see that in our structural formula here. We have our chlorine on the second carbon, and it's a 3-carbon chain called propane. So 2-chloropropane. So we look at our example. We see we have an attached F, so that's a fluoro. We have 3 carbons, which is prop, so it's still propane like the example. This F is on the second carbon, so it is 2-fluoropropane. If we have more than one of the same halogen, we're not going to say it twice, so we're going to say di, tri, etc. So in this one, we have 2 carbons, that's ethane. We have a bromine on the first carbon and a bromine on the second carbon, so we would say 1,2, and instead of bromo-bromo, we're going to say 1,2-dibromoethane. For the alcohols, alcohols have the OH functional group attached, and we look at their example. It's propanol, which means it's 1, 2, 3 carbons. We have the OL, the alcohol, attached to the end, and the 1 indicating it on the first carbon, as we can see here in our structural formula. And the rule of thumb is whenever they give you a number in their example, that means you should be numbering your functional group for the most part. So let's look at an example. We locate our functional group first, which is the OH. We know it's an alcohol. This has 4 carbons. 4 carbons is bute. So instead of propanol, this is going to be butanol. And the OH is on the first carbon, so that's going to be 1-butanol. Let's check your understanding. Can you identify functional groups for halides and alcohols, and can you name halides and alcohols? The next class of compound is the ether. The ether has an O sandwiched in between carbons. And since it's breaking up the chain, you'll notice that the name is 2 parts. Methyl ethyl ether. So our ending is going to be ether, but let's see where the methyl ethyl is coming from. So methyl is 1 carbon, that's coming from one side of the O, and ethyl is 2 carbons coming from the 2 carbons on the other side. So basically naming one side then the other, and we typically do it in alphabetical order, although this is an exception to that. So let's see an example. Here we have our O, our functional group, so we know it's an ether. We know the ending is going to be the word ether, so now we're going to look at what are our 2 sides. Well, this side has 1 carbon, that's meth. This side has 1 carbon, that's meth. So it's methyl-methyl ether, and again, we don't like to say the same word twice, so we'll say it is dimethyl ether. Now let's look at the aldehyde. The aldehydes have a C double bond OH as a functional group, and it's located at the end of a compound because we only have carbons on one side as indicated here. So look at their example, propanal, 1, 2, 3 carbons is prop, that's where that's coming from, and they're using the AL ending. So if we get an example, we first locate that functional group. We know it's an aldehyde. We know the ending is AL. We count how many carbons we have, which is 4 carbons. 4 carbons is bute, so instead of propanal, we're going to have butanal. The ketone is very similar, but now the ketone has the C double bond O, and it's sandwiched in between carbons, so it's not at the end of the molecule. Looking at how they name theirs, pentanone, pent is 5 carbons, 1, 2, 3, 4, 5. That's where that's coming from. The ending is ONE, and the 2 giving the location of that double bond to oxygen. on the second carbon. So once we locate our functional group, as we do here, the C double bond O, we know it's a ketone. We look at the name and we look at how is ours different. Well, we have 1, 2, 3, 4 carbons. So 4 carbons is bute. So instead of pentanone, this is butanone. Now, what carbon is it located on? 1, 2, it's on the second carbon, so this is 2-butanone. Let's check your understanding. Can you identify functional groups for ethers, aldehydes, and ketones, and can you name the ethers, aldehydes, and ketones? Now looking at the organic acid. Organic acids have this C double bond OOH as the functional group. It's located at the end of a molecule. Looking at their example, propanoic acid, prop meaning 3 carbons, so this has 3 carbons, and then we're adding oic acid as our ending. So looking at an example, when we locate this functional group, C double bond OOH, we know it's an organic acid. We count up the carbons, 1, 2 carbons. 2 carbons is eth. So instead of propanoic acid, we have ethanoic acid. Now looking at the ester is like an organic acid, but now this functional group, the C double bond O, is now sandwiched in between carbons. It's not at the end. And so because it's breaking up the chain, we're going to have 2 different parts to this name. This says methyl propanoate, methyl meaning 1 carbon, so that's on this right side of our functional group. And then prop meaning 3 carbons, this is the left side of the functional group, including that C double bond to O. So we're going to locate our functional group in this example. We see it here. We know it's an ester. We're going to name the right side first as they did in their example. So it has 2 carbons. That is eth. Then we're going to name the left side, which contains 3 carbons. That is going to be prop. So this is, instead of methyl propanoate, this is ethyl propanoate. Let's check your understanding. Can you identify functional groups for organic acids and esters, and can you name organic acids and esters? For the amines have a nitrogen as the functional group. And looking at the example they give you, the ending is going to be amine. It says propanamine, prop meaning 1, 2, 3 carbons, so that's where the prop part comes from, and 1 indicating that it's on the first carbon. So we can see that in our structural formula here, that this N is attached to the first carbon. So looking at an example, when you identify that functional group, that N, we know it's an amine. We know the ending is going to be amine, and so now we're going to count the number of carbons. We have 1, 2 carbons, that is eth, so it's going to be ethanamine. And in this case, we don't really need the 1 because if you put it here, it's still on the first carbon, but if you put it in, it would not be really incorrect, and we would give you credit for it. Lastly, we have the amides. The amides are different than the amines because they have a double bond to oxygen as well as the nitrogen in their functional group. Looking at the ending, the suffix, it is amide, and so propanamide, we have 1, 2, 3 carbons. 3 carbons is the prop, and that's where that's coming from. And so when we look at an example, we locate our functional group, we know it's an amide, we know our ending is going to be that, and so now we're going to count up the carbons. We have 1, 2, 3, 4 carbons. 4 carbons is bute, so instead of propanamide, we're going to have butanamide. Let's check your understanding. Can you identify the functional groups for amines and amides, and can you name amines and amides? At this point, you should be able to identify functional groups and name substituted hydrocarbons.